Thank you. We can start.
Great. So I am talking about merging split alpha, project I have been working on for several years. So let's start with some context. So in the beginning, the graphics world was formless and without transparency, also known as alpha. This was a long time ago, back when Star Office days, and we started out life with graphics in computers in general without much in the way of transparency or alpha stuff. So the first thing we did was we created something called masks. And masks allowed us to punch little holes in our pictures and show through underlying stuff. And that was great. Masks were useful because they were essentially just bitmaps with 1 bit per pixel, just saying whether it should or shouldn't show through the underlying stuff. So that's how things started. Unfortunately, there is a hang of a lot of mask-related code throughout LibreOffice to this day. So then we added transparency. And initially, transparency was a separate layer. It was a separate bitmap with values, initially 4-bit values, and then later on 8-bit values, indicating how much transparency there would be. But it was a separate layer. The graphics cards would use these layers to combine multiple color layers. And that was useful, but it was really a pain to work with. So then pretty much everybody switched to 32-bit color and alpha. And we merged the two together, so you had 32 bits with 24 bits for color and 8 bits for alpha, all packed into one 32-bit word. And that was much easier to deal with because as you were rendering each individual pixel, you could, as a programmer, that is easier to deal with, you could decide whether or not to make it transparent or not. And that was pretty straightforward to work with. However, the first problem. In the beginning, there was some debate about whether we should be working with transparency, i.e. 0 meaning no transparency, all the way through to 255 meaning full transparency, or alpha, which has the inverse scale. Now, Star Office chose transparency, and unfortunately, at some point later on, alpha pretty much became the de facto standard with all graphics engines. And unfortunately, we were stuck with transparency. And transparency is throughout our code base still to this day. So I started my transparency work, the first stage of this, which was converting transparency in LibreOffice to alpha. And I started in 2019, and it took me a couple of years with several false starts, trying various things to land a patch. That patch had to be reverted within a month because it caused so many regressions. And then tried again a few months later, once it was a little bit more stable, and got it committed. Initially, things were working, but that was just the beginning. So there was a long slog. It was a long slog. So I fixed a lot of bugs, and the bugs kept coming in, and eventually I got so tired of this, I was just about to give up. But then Patrick Luby very happily, very handily came to the rescue, and he started helping me, and that gave us the push to finish the work. And we've been fixing bugs, and I think we've only fixed 2 or 3 bugs this year, but still, the last bug was a month ago. So it's taken close to 3 years to fully stabilize this work. It's been a long slog with so many weird corner cases to investigate and track down and figure out what the code wanted to do and what it was now doing and how that interacted with various layers of the graphics stack. So the current architecture we have in LibreOffice. What we have now is we have at the top, from a programmer's perspective, something called a virtual device or an output device, which is also pretty much the same thing as a window or a frame. It's a surface that you render stuff to. And you render using bitmaps. And a bitmap internally wraps something called a cell bitmap. And a virtual device internally speaks to something called the cell graphics. And the combination of cell graphics and cell bitmap gets handed down to various backend layers. We have multiple layers, more layers, in fact, than we have supported operating systems. So, for example, there's Quartz on macOS. There's also Metal, Skia/Metal on macOS. There's Cairo on various platforms. There's OpenGL on various platforms. There's GDI on Windows. There's a lot of backends that we deal with. So from the perspective of bitmaps, we have a bitmap, which wraps a cell bitmap. We have something called bitmap X, which is mostly what we deal with in the code base. And a bitmap X wraps two bitmaps internally. One of them is the color layer. One of them is alpha layer. Output device also has two things. It has its primary cell graphics backend, and an output device wraps another internal output device. As you can see, that is the actual code, what the actual code says, //temp. And that secondary thing handles the transparency. So that's been in their code base for a very long time. And even back in the beginning, people knew it was something that shouldn't be there for forever. But anyhow, it's been there for a long time. So my plans for this stuff. My plan started out as, let's see if we can merge the two bitmaps that live inside bitmap X into one bitmap which handles transparency using 32-bit. That did not work out. I've tried that 3 times so far. Every time I got bogged down in various places that it was just impossible to handle cleanly or to do it incrementally. So, second approach, instead of starting there, start with the output device / virtual device and make that render to a 32-bit merged color alpha surface. So that is currently a single fairly large patch. It touches all of the backends and all of the platforms at once. And yeah, it's entertaining. So the downside of doing this approach is that there are probably going to be a lot of regressions. The upside of this approach is that instead of trying to incrementally change the backends and having multiple flag-dominated paths through the various layers of the graphics stack, we'll only have one path to the graphics stack that has to handle 32-bit data. And the reason that I'm trying this approach now is that it is just vaguely possible for me to keep most of one path in my head. 2 is utterly impossible. Smarter people than me have tried to do this incrementally and failed, so I don't feel too bad about this. So yeah, that is what I'm going to attempt. So why is this all so terrible? Well, cell bitmap has multiple backends, one per platform. Some of the platforms have multiple backends themselves. There are many optimized and semi-optimized kind of things that wind their way through this graphic stack. They all attempt to improve the rendering, and most of them do, but it just means that there's an awful lot of methods and function calls at every layer that have to be accounted for. And they often do things like, does the layer underneath me support this? Then implement this optimized path, otherwise fall back to some other path. At least one of the backends cheats and sometimes uses 32-bit color alpha already, which is insanely confusing. And then there are at least 2 and possibly more flags that are related to people's previous attempts to do this work. And yeah, those make life more interesting as well. And then on top of that, we have pre-multiplied alpha, which I won't go into that now, but sometimes the alpha value is multiplied into the color value and sometimes not. And mostly we don't do that, but some of the layers seem to think that we do. I'm still not clear on exactly what's going on with the pre-multiplied versus non-pre-multiplied alpha. I'm still figuring that out. And right now, all I have is a preliminary patch, which compiles and manages to bring up a very basic LibreOffice window without asserting or crashing. So for me, that is great progress. And yeah, there's still a long road to walk to get this to a working state, and then there's going to be a long road to walk to get it to a state where it's regression free. But the end of this, we hope, is that we get to a better place where our color and alpha layers are nicely merged, and we can basically bypass a lot of the copying that we currently do and kind of render directly to underlying surfaces that we can share nicely with the graphics card, and yeah, just get a lot more bandwidth out of our graphics layer. And that is me. Yeah, questions?
Woohoo! Thanks, Noel. Great work. It's really encouraging to see a summary of it. It's a lot of aggro there.
Yeah.
To what degree is the Cairo? You mentioned one backend, and it's the Cairo backend, right? Which is already
Yes.
doing
Yes.
alpha rendering, I think, for output devices, isn't it?
Yes, it is. It is. It's a bit of a hack, but it manages to make it work in some cases, which is useful. But it just makes converting the code confusing because the other backends don't. So it's just another thing to handle.
Interesting. And are there lots of conditionals for that case going through the code already, or how does that work when we take a split alpha and render it to the Cairo backend?
There's various magic. The Cairo backend has it kind of knows that some of its surfaces are already merged. It has various checks that it does for that. So it effectively keeps track of state internally as to whether or not things are merged.
Oh, cool. Right. So we can see then if another surface is the Cairo one, and thus it has pre-multiplied alpha, and life is good, and so on. That's
exactly.
Good. Oh, nice. Okay. But you don't want to sort of extend that approach to tag lots of surfaces as whether they're sensible or not, and do it one back end at a time then?
That is possible. It could be done, I suppose. It's worth having a look at.
But you're getting there anyway, you say?
I hope so. I hope so. I've got something that kind of starts, but it's still got a lot of. It's most of the unoptimized. I mean, the unoptimized paths are actually not that hard to work with. It's the various optimized paths that I still have to debug.
Okay. Nice. I'll shut up. Anna, you going to poll people for questions?
Yes, yes. Thank you, Michael. Thank you, Noel. And Aidan, any questions?
Nothing from my side. Sorry, nothing from my side.
Okay, thank you. Miklos?
I would have a question about the PDF export side of things, where we kind of subclass an output device, and it's like it's a question, so I don't know exactly the situation, but it seemed like at least years ago the PDF transparency model was kind of close to this double output device approach that we have. And like, did you run into that already? That in case you do the right thing here, then that causes complications elsewhere, or perhaps that PDF thing is already very much outdated, and these days PDF could handle transparency out of the box, or do you have any view on that?
I don't know what's going on down there. I think the PDF stuff is mostly okay because it effectively overrides kind of the bulk of what an output device does. So it kind of does its own thing and skips the most of the logic in output device, most of the complicated logic anyway, and then it does its own thing. So it's kind of isolated in that sense. So it'd actually be easier it actually shouldn't be terribly hard to make the PDF output device do transparency.
Thanks. So that's good to hear. And the other small thing is that just if it's possible to do this incrementally, then I would like to just encourage you to do it that way. We had many large changes, like just think about welding and other things where it seemed that the lesson we learned is that either you can do it incrementally or you can do it. And it's possible that this is large enough that like at the end the lesson we learn here is similar, but of course up to you. It's just a suggestion.
Yeah, if I can do it incrementally, I certainly will. I'm not sure that it's possible, but I mean, it wouldn't be the first time that I've written most of a patch and then kind of ripped it apart and started again with a better approach.
Anyhow, thanks for looking into it.
Thank you, Miklos. Zenda, questions?
Sorry, no questions from me.
Thank you. Jacob? Questions, thoughts? We can't hear you, Jacob. Okay, Andras? Questions, thoughts?
No, thanks.
Okay, next is Attila.
Hello, I don't really have a question. I just want to mention that I like these topics. I worked as a in game industry, but there we always had one standard way to handle alpha, and it's much more confusing here that I never know if in different ways what we are doing. Thank you.
Thank you, Attila. Bayram? No questions. Kellen?
Yeah, no particular question. It's just kind of some thoughts. I can't remember what it's called at the moment, but we have this thing where we query the backends in VCL, and we query for stuff like, are the backends able to do things? And that's just one thought that always comes to mind. There is, I wonder, has anybody checked to see if all of our backends actually have, all of our remaining backends actually have all of the options that have been queried for? Because we have all of these fallback paths that says, if the backend can't do something, use this fallback route. And I just always have this thought that maybe all of these fallback routes are all dead code in practice, and it just might just shrink kind of some of the problem down. So there might be fallback codes that use masks, and maybe they can go away because all of our backends currently support a different way of doing things. Just one thought comes to mind. And I guess the other thought then is, there's a lot of places that still use masks. I guess we're probably stuck with supporting masks because they exist in meta files. Do you know if that's true, or just maybe something that doesn't matter?
I don't know much about the masks. I did do a check through all of the backends as far as what things they support and what things they don't. Unfortunately, so the dumbest backends are the PDF backend and the Quartz backend. And unfortunately, those two account for most of the kind of fallback paths that we use.
Yeah. So we're still stuck because of the Quartz issue. Okay.
Yeah.
And then there was just one other thing on that path was I think Lubash added some support for things. They just mentioned that they were possible in the Cairo one as well. But I guess that thought doesn't matter if you're blocked on Quartz. Just apparently there are some paths that are not implemented in the Cairo backend that could be implemented. That's as much as I remember Lubash mentioning at one point. But if Quartz is the blocker, then that doesn't help anyway. That's it.
No, unfortunately.
Okay. Thank you, Kellen, and thank you, Noel. Carlo, questions, thoughts? We can't hear you, Carlo.
Sorry, no questions for me. Thanks.
Okay, thank you. Cosmin? No questions, okay. Darshan? No questions. Hussein? Jaume?
No questions, thank you.
Thank you. Joao? Okay. Mike?
No questions, but a big thank you. And it's very encouraging to see what you're doing now. Thank you very much.
My pleasure.
Thank you, Mike. Michael Stoll?
No questions.
Ezine?
No questions from me. Thank you, Noel, for the presentation. Thank you.
My pleasure.
Pranam?
No questions. Thank you.
Thank you. Raj, questions? Okay. Stefan Berg, questions?
No questions. Just good luck with the ongoing work, Noel.
Thank you.
But while Stefan is unmuted, I saw there was something around this X bitmap interface. So one of the questions is, did we accidentally standardize split alpha or funny mask or something at the UNE level, and do we care about that? And or What's the what is the scripting story on all of this? For either Stefan or Noel or both. You know?
Sorry, I completely don't get you.
So there is this X bitmap. I just wonder if we export, you know, give me a whole load of numbers out of that.
I don't.
Did my question make any sense, Noel?
I haven't hear about it. So you're speaking about some Uno interface, XBitmap, or what?
Yeah. I just wonder if we have an API through Uno.
I don't hear about the details there. Sorry.
Okay. Noel, do you know?
No.
I think we do, unfortunately, export at least some of that XBitmap stuff to scripts. I have a vague understanding that some ways some people are actually using some pieces of it, but not very much.
Okay, and that exports a split alpha API or a RGBA thing, or I just wonder.
I think it exports both, to be honest. I think you can ask it for either.
Okay, fair enough. But there is a new fast path that we could add, perhaps, or not.
I don't know. I've never looked deeply into that.
No one uses it anyway, so it's probably not a very important piece, perhaps, at the moment.
No.
Cool.
No.
Okay, thank you. And
I'm sorry. As far as I know, our XBitmap exports DIBs both for main channel and mask DIB. But I believe that we would just need to provide it. And also there is a way to get both in get DIB in normal channel. So possibly it wouldn't be very difficult to provide fallback for mask DIB and by default get everything in the mainstream. I hope so.
Sure. I just obviously there's a compatibility thing here, and Stefan's an expert on, you know, where to bend the rule or where not to, or I don't know. So we're just interested in if there's an issue there, but it sounds like there isn't a big one.
So it looks like these methods return values, so we can just return some converted value for compatibility.
I'm not sure if there was a question there or not. I couldn't understand. Michael, there's too much background noise.
I think we're good. Let's move on, Anna.
Yeah. Okay, I see also Vivek doesn't have questions. If no questions, thank you, Noel, for the presentation, and thank you everyone for joining. See you next week, and bye-bye.
Awesome. Thanks, guys. Bye.
Bye.
Cheers.
Bye.